with that, I'm going to go ahead and turn things over to TJ and our talk on Docker.
All right, so I'm TJ. I was actually involved with this meetup back when Caddis had the meetup and started the meetup, and I was at the company when the meetup started, and then COVID happened, and I haven't been in a while, and last month I came, and that was a lot of fun, so just trying to get reconnected and see a lot of new faces. I also just got back from a 1-week vacation, and then I was out for a week at a conference, and I was going to run through this talk again last night and then this morning, and none of that materialized. So it's been several days since I've seen this talk, so bear with me as I remember what some of my slides are about. So I'm going to go ahead and dive into Docker. Who all has heard of Docker? Who all has used Docker? Okay, so hopefully you'll get something out of this presentation. When I started using Docker, I found that one of the problems was I didn't understand, even though I was using it, I didn't understand some of the concepts, and I feel like a lot of that can be dispelled and kind of laid out. Docker is, in some ways, the promised land, which I'll get into, of the various disparate environments, and Docker kind of is your environment, which is great. So I'm already kind of talking about it. Why Docker? Well, the disparate environments problem is a real thing. There's a lot of tools that you can use to make your local environments run. If you're on the Mac, MAMP was a big one back in the day. Or if you're on Windows, WAMP or XAMPP. There's Laravel, there's EasyPHP and Vagrant, or you can install the tooling that you need. So it's kind of used to be a wild west out there, how to get your local environment running. You're going to need some sort of web server. You need usually a backing technology like Node or PHP or Ruby. And you're almost always going to need a database, maybe Redis, Mongo, et cetera, et cetera. So getting all that stuff up and running on your local computer can often be a challenge. And in addition, then you have the problem of the environment being very different from production. So your environment, getting your environment up and running when you get started on a project, you get to a new company, or the company asks you to move to this project that they have, or what have you, is often clone the repo and just make it run, right? That's not a great solution for everybody. So you often wind up with the age-old problem of it works on my machine. I don't understand why it's broke in production, right? And Docker doesn't completely solve that, but it eliminates a lot of those things where the environment is so different from one computer to the next, and from production to development to staging, that you run into these problems of I cannot replicate the issue that I'm running into in production on my development machine, or vice versa. So this way of working can be very fragile, and it can be very difficult to do. So that's where Docker enters the picture. Docker is one of the ways to help reduce those pain points, to start narrowing down how many things can be different from environment to environment. So I would contend that Docker is a much better way. There are other ways that are similar to Docker. Docker is the one that I know, and it's the one that's the most popular, I would argue, and it's the one that I use both personally and at work. So Docker is a way to package up your applications so that they run anywhere Docker can run in a predictable and reliable way. But in order to use Docker, as I mentioned at the outset, I think it's important to start understanding the basic concepts so that you're not just throwing a bunch of Docker at it and hope that it works. Understanding what Docker is doing and some of the terminology that's used is very helpful, I think, in using Docker. So we're going to talk about what Docker is, what it does for us, and what the key concepts are. So first and foremost, Docker is a containerization technology. So thanks, TJ. What does that mean, right? So simply put, a container is a package of software, and all of that software's dependencies so that software can run. The goal is to abstract the platform away and give the application the same environment to run in every time and every place it runs. I found an article back when I was developing this presentation, which I gave at work when we switched to Docker. So I don't know if it's still there, but it was on Citrix.com. Containerization is defined as a form of operating system virtualization through which applications are run in isolated user spaces called containers, all using the same shared operating system. A container is essentially a fully packaged and portable computing environment. So let's talk about containerization. So containerization packages up everything needed to run the application. This includes binaries, libraries, config, dependencies, the software itself, you name it. You're gonna package up everything into an image that runs as a container. This abstracts the platform from the host OS, right? So anywhere that Docker can run, your image can run. That's kind of the idea. And I'll talk about some of the nuances of that in a minute, but that's the general idea. So this reduces or completely removes differences between environments and platforms that cause those hard to track down bugs. So you're removing all those differences so that everything in the container is the same environment everywhere you go. It is not a VM. So I transitioned from running stuff on my computer to running it in a virtual machine to try to reduce those things. But that's a huge thing, right, that your computer has to run. But it is not a VM. Because a container shares the kernel and resources with the host OS, so this provides native or near native performance. And I'll talk about let's talk about that caveat now. That's actually my next slide. So containers run natively on native platforms. So of course Mac OS, Windows, what have you, is not a native platform for Linux containers. Even though Mac OS's kernel Darwin is not it's not a Linux kernel, even though it's very Unix-like. The same goes for Windows. So Docker for Mac and Docker for Windows when you're in Linux mode, because you can run Windows containers, which is beyond the scope of what I'm talking about today. I'm a Linux guy. So Docker for Mac and Docker for Windows run a Linux VM in the background. So you are running a VM on your development platforms, but it's very well optimized, and these days you don't really notice it anymore. Or on Windows, you can also run in a mode that uses WSL2. It's been a couple of years since I've used Windows for development. I did do development on Windows for a couple of years, and WSL2 wasn't a thing yet. I hear that's very fast. I didn't get to use that. You can do all sorts of things to improve performance, but it won't be production performance, but it's perfectly fine for dev. I've not really had any issues up there. There was a time when the Docker desktop application and its VM ran a little bit slowly, particularly on the Mac. They've solved most of that, so doing development on your local dev isn't very slow anymore. Now, as I said, I am going to be talking about Linux containers. Windows containers, virtualizing Windows is totally a thing. I've even done it a little bit, but it's not my jam, and I'm not at the company where we do that anymore. So I have very little experience with it, and I'm going to be talking about containerizing Linux. That said, most of the stuff I talk about should be conceptually the same. To be clear, Linux containers can run obviously on Linux. Also, they run via Docker Desktop on Windows and Mac OS, anywhere that Docker Desktop can run in Linux mode. So, key concepts of Docker. So you have a Linux base image that starts out with it's a very light userland implementation emulated in the operating. I'm tripping on my words. It's a very light userland implementation of Linux. And then the host kernel is leveraged for those underlying OS calls. So again, it's not a VM. Those calls are sent right over to the operating system. Developers then use what we call Docker files. They're literally just named Docker file to create images with libraries or files that the application needs to run. Developers have created many images that can be used as starting points. So you don't have to start with just that base Linux implementation. You can start with any Docker, any image out there. For instance, my company, we have a legacy app that we've only been able to get up to PHP 7.2. We're up in PHP 8.1 now, I think. But we can only get that application up to 7.2 at the moment. So we're starting with an image in the Docker Hub registry called PHP 7.2.34. That's where we start, and then we build a few things on top of it. We don't have to build the entire implementation out in our Docker file. So I've mentioned images, I've mentioned containers, I've mentioned a bunch of things, registries. Let's talk about what those are. So images. Images are created from that base OS image that I mentioned. They're defined by and built from Docker files using the Docker build command. Images are self-contained bundles of libraries and code. And then images are sort of these inert, immutable files. They're snapshots of the state of the file structure when you build it. Everything that you built into that image, it's sort of a snapshot. and it should include everything that you need to run that application. And so images exist in, I would contend, confusingly named container registries, because containers are related to images, but they're not images, but the images live in container registries. Naming things is hard, as we know. So container registries hold Docker images. So your dev environment, your build server, etc., they have a local cache or a local store of the images that you downloaded from container registries. The Docker Hub is the big container registry, right? It's like the default container registry. And this is an important concept, you can host your own private registries or leverage other private registry hosting services like GitHub or DigitalOcean have these services for you. And that's important because a lot of us don't want to push our app images of proprietary code out to the main Docker Hub, which is public. We want to keep those private and then deploy them to our private servers. So that's an important concept, is you can host your own or you can take advantage of private hosting for registries. So containers, I mentioned images and containers are related, but they're not the same. And this is a subtle difference. Containers are running images. So when you start running an image, it becomes a container. That container is up and running, so it is the container running things, and it's running from an image, which I just said. Programming metaphor this is something I like to use. An image is like a class. If you're an object-oriented programmer like I am, an image is like a class, and a container is like an instance of that class. So it's a runtime object, so to speak. That's sort of the analogy that I like to use. So just like a class is a definition or a blueprint to construct an object in object-oriented programming, this is what an image is. It's a definition that the container runs from. An important concept that you have to talk about when talking about Docker is ephemerality. So unless you take steps, anything that happens in the container is gone when that container is spun down. There is no such thing as saving inside the container. Containers, when they're restarted, they start back up from that image, and nothing that you did matters inside that image. Whatever you saved to disk, whatever, it's gone. Ephemeral meaning lasting for a very short period of time. So when you take that environment offline, everything saved to disk is gone, and any need for permanent storage then needs to be achieved by mounting in a volume into that running container. So this is a very important concept to understand. If you assume that things are going to be saved when you do stuff inside the container, you're going to have a bad time. So volumes. Volumes are the mechanism we use to persist data inside of Docker containers. So volumes can be local file system resources. You can directly mount things from your file system into the running container, and they'll be mounted at your specified mount point. They work just like mounts do in Linux, if you're familiar with that. There's articles and things out there. Just know that we're mounting resources from outside the container into the container. If you mount a directory, then anything you do in that directory will be translated both ways. So Docker Compose. So most applications they're going to need more than one container. You're going to need perhaps a Redis instance alongside your application. Your application container is going to need other resources. So we need a way to orchestrate the containers together, and that's where Docker Compose comes in. It's a built-in Docker tool for defining a multi-container application. And they're, Docker Compose and its sibling, Docker Swarm, like all these things are related together, but the concepts are the same. So we use in Docker, it's a YAML file. The Docker Compose file is a YAML file for definitions about you and defining things about your multi-container environment. Those of you in the Ruby world will love that. That is a Ruby thing, right? That's where that originated? I think that's right.
YAML, maybe.
Yeah.
It's used.
Yeah. So you can specify, for instance, your volume mounts, because by default, if you're just using the Docker up command, then you have to specify all that stuff in the command line every time. And when you use Docker Compose, you've defined all that stuff already. I don't use Docker pretty much outside of Docker Compose. Like once in a while, I'll spin up an image or a container to test something or whatever. But most of my projects are using Docker Compose, and we do the same at any company that I've worked at where we use Docker. So here's an example, very simple example, Docker Compose file. You define your services and the services key. So that, you know, every key within the services key in this array is a container in your project. For instance, here's the application container. This one I'm just running straight from the Apache Buster, PHP Apache Buster image. Since only, this is a little bit harder to explain. I'm trying to find the definition of where to cut things off in this presentation and not dive too deep, but you can only one process can own a port on a host, right? So what I tend to do is map a random port into port 80. I say I tend to, there's a lot of other ways to handle it. This is just a simple example. If I didn't want to have other orchestration things happening on my computer, you can get to this at port 5000, basically. And then for the purposes of development, this Docker Compose file, I'm mounting the entire code base into the container. So when you build an image, for production, you're going to include all of your code. When you're developing, you want that to be reflected when you're working on your computer. You want whatever you do to be reflected in the file system in the container. So this is just mounting where I'm starting with dot, and then I'm mounting it into the place where it's expected to be in the container. This is the database that I'm running in development. Again, for production, you may or may not run your database in Docker, or you may have a managed database service you're connected to. For development, I'm running a database, and then I am mounting a volume. So I'm defining a volume that Docker, so you can mount file system resources, or you can define a volume that Docker Compose will manage, and it's just somewhere in the file system that you don't need to know about, and then you mount that into where you need permanent storage. In this case, I need MariaDB, which is a drop-in replacement for MySQL. I need to give it a place where its data is stored and where it's expected to be, so I'm mounting a volume there so that data persists across restarts of Docker. And this is where I'm going to go into a demo. So I don't usually do this in my presentation, so I'm branching out a little bit. I'm going to switch over into a live sort of mode. Okay. So let me pull up. I meant to have this up before we got started, and I forgot. So I think that's in presentations. Here. Demos. All right, here we go. All right, so this, let's start with this Docker file. This is not much different than the Docker file I showed you in that presentation example. I did change port 5001 for reasons I don't remember. Maybe I already mapped 5000 to something else on my computer. I'm still mounting the code base in there. I'm still using MariaDB. I did set some environment variables so that most Docker containers often have environment variables to define certain things, either ongoing when they first start up. In MySQL's case, or MariaDB's case, if you define root, password, user, and password in your environment, then it'll pick up those things when it starts up. And then for grins and giggles, I defined a Redis container that should also start up. So let me here. And Docker Compose up is the command. Now see, it's running autocomplete -D. Let me tell you the difference here is if I were to not use -D, which stands for detach, Docker would spin up and it would run in line, and when I close this terminal session or Control-C interrupted it, Docker would spin down and go away. -D will detach it and continue to run in the background so I can go do other things in my terminal. So that is up and running. If I do Docker PS, that lists all the running containers. So you can see there's my PHP container, my MariaDB, my Redis container. All right, was there anything else? Yes, so I'm going to echo hello world. I'm a PHP guy, sorry. I know that some of you didn't hear Ruby and other languages. I'm going to echo hello world, simple, but then I'm also going to try to connect the database. That's going to fail because the vanilla PHP Docker image doesn't have MySQL drivers. I want to show you the failure, and then I'm going to show you how to address it. So let's go to port 5001 on my local host, and you see it echoed hello world, so that's all running in the container, but then it can't connect to PDO, can't connect to the MySQL server because we don't have the right drivers. So that is the first demo. Let me go ahead and spin that down. So Docker compose down. And I think the next thing is questions so far. Right, so does anybody have any questions? Have I been unclear on anything? I know I was talking about a lot of concepts, so if anybody would like any clarification on anything, feel free to speak up. Yes?
I'm very new to the IT world, but I was wondering if you could define what persisting data means.
So when you have a Microsoft Word document, it saves to a file on your computer. Well, even that doesn't work these days because of the cloud. Generally speaking, in the old days especially, you have a file on your computer, and when you do data and you save it, you close Microsoft Word, you come back and you open that file, all the data is still there.
Right.
And it's saved on disk. Docker, because it's spinning up from a predefined image, and so every file system resource inside that container comes from that image. So if you've done any persisting of data, you saved anything in a database, you've saved a file on the file system or what have you, when you spin down the Docker environment like I just did, Docker compose down, when I spin it back up, it's gone. It's not there. It didn't get saved anywhere. So to persist that data, you have to do something, tell Docker where to save it, basically. And so Linux has this concept called mounting. So we're mounting something from the outside into the Docker container so that everything you do in that directory is mirrored on the outside of the Docker container. And then when you spin down the Docker environment, all that stuff is still in that folder on your host, and so when you spin it back up, it mounts it back in there and it's all still there. Does that make sense?
It does. Thank you very much. Appreciate that.
Anybody else? Yes?
I'm curious to hear what you had to say about caching strategies when it comes to building your images.
I can speak to that a little. In fact, I think I might have a little bit when I get to some more demos in the future. There might be some more of that. But if not, bring that up again and I'll try to speak to it.
Cool.
Yes?
I have one. So in the web world, port 80 and 8080 mean things. In the Docker world, does it have a standard set of ports most people use for?
Yeah, so Docker uses its own networking internally, and of course, any port 80, port 443, port 8080, all that stuff, it is what it is inside the Docker world, but then you have to map it to the outside world. So what I was doing was mapping a random port into port 80 in the container, so that from the outside, I hit port 5001, and then that hits port 80 inside the container. 80, of course, is the standard non-SSL port that the web is served over.
Right.
And then if you're trying to hit 443, same thing, you need to map another random port. Now there are other strategies to get around that. I actually run a Docker container called Traffic, which is always up on my system. And when I define a few more things in my config, then Traffic picks it up and it just routes it over. So that container actually owns 80 and 443 on my local dev.
In the Docker world, are there standard ports I generally use to talk to those ports? Is there like a best practice you found? Most folks you're using 5,000 and in that range. Is that the standard, or is that
no? So each of my projects, if I need access to something that's on a standard port, I generate a random port for every project so that there's no collisions. And like I said, I actually don't have much of a need for that because I run Traffic, which owns 80 and 443 on my computer, and then it does the proxy routing to the correct servers and ports, correct containers and ports. So it's a little beyond the scope of what I'm talking about, but it's a very relevant question because it is a problem that you have to contend with. And I just lost it. I let it go to sleep. There we go.
To build on that.
Yes.
To build on this question. There you go. I got it. Could I have two, because you've got the port mapping, right? Could I have two different containers that internally are running Apache on port 80 on the same machine, or would that be?
Yeah, no, you can have the containers can all be running their own ports internally in Docker's network.
And so really it's just the extra, I don't know how that works though, because they're still using the OS underneath. So
Well, yeah, but it's all, the networking is internal. So Docker has its own networking strategy internal. And so there's a key in Docker Compose that I didn't show, and it's also a part of the parameters if you're using the command line, which is expose whatever port. And that exposes the port into Docker's networking, but not externally. So there's some nuances there. And like I said, I was trying to draw the lines of how do I have a tight presentation.
Yeah.
But there's a lot there, and ports can be challenging for sure.
Yeah.
Because they are anyway. So. Okay, we'll have more time for questions. There are some things that I wanted to go over. So I want to solve the PDO problem that I showed you. So this is like pseudo live coding, like I've already done it once and I sort of have it all up here. So let me open demo 2. Okay, so now you can see that I'm using an image called docker-demo-02. Well, what's that? That's not coming from anywhere, right? That's just some random name that I gave it. So we'll talk about that in a minute. Everything else pretty much looks the same. Really, the only thing I've changed is the image that we're going to run. And so the way that we're going to get that image, in fact, if I were, let me do this real quick. Dang it. Docker, if I do docker compose up right now, it's going to fail. It's trying to pull that image that I specified. It can't find it. It says pull access is denied, or the repository doesn't exist, or something went wrong. Go fix it, right? So here's how we're going to fix it. What we've done now is we've defined a Docker file. So I'm still starting. We have this, and again, you can read up on the documentation of Docker files, but we start from something, right? We're starting from that same image that I was using a minute ago, but now we're going to run some commands that install the things that we need. So I'm in a Debian-based, Apache Buster is Debian. So we're going to run apt-get update. We're going to install a few things like, well, actually, we're just installing one thing in this instance, the default MySQL client. And then the PHP Docker image has a command to install extensions. Normally, you have to do a little more work than this if you're doing it manually with makefiles and stuff. But this actually just has a command inside that image to actually install things like PDO MySQL. So it's going to run those things, and then it's going to create an image. So I have the build command. I usually use scripting to do all this rather than try to type it all out in the command line every time. So I have a script here that's going to build that image. I'm specifying an environment of Docker build kit. That's just a newer engine to run a Docker build. You could totally omit this environment variable, and it would still build. It would just be a little bit slower because of using an older engine. Some things in Docker are a little bit messy. Just some things you have to learn as you go. So yes, and I'm also telling it to use inline caching. This may address what you're talking about. So normally, if you don't have something that's caching, every time you build, you are building from scratch. However, you can tell Docker to build in caching hints into the image, and then you can tell it to cache from the name of the image that you build caching hints into, and then future builds will be much faster. It will only build what it needs based on what you changed in the Docker file. And then I'm telling it what Docker file to use for the build, and then I'm telling it what to name the image it's called tagging. We're going to tag the image with this name that we're about to write, and then finally I give it the context. So the context is the place in the file system where you're building from. So anything in that context is available to the Docker build. I'm not doing that in this Docker file, but you pull in your application from your context and build it into the image, which if I was timed, I will demo later. So let's go ahead and build that. So I'm going to run, what's it at? It's docker build.sh. So I'm going to run that build script. And you can see here, it tried to import that image for caching and couldn't find it, so it built it from scratch. And so now it's built it, it's exported it, and now it's in our local cache of images. If I were to build that again, it would be very quick because it got everything it needed from cache. So now when I run docker compose up, it will be able to run it. And if we go back to, I haven't changed anything here other than removing the comments that said it was going to fail, because now it should be able to connect to that database. And there you go. I'm just var dumping an object of PDO, but there was no error. You saw an error before, now there is none because PDO connected to MySQL because we built in the drivers into that image that was needed. So this is the part where I say you're eliminating differences between your environments. If you had a local dev environment where the PDO driver for MySQL was not installed, you would get that failure. Or you installed it and it was working in your local dev, and then you deployed to a vanilla PHP production machine, it would fail if the PDO driver, the MySQL driver, it wasn't available in PDO. So now we've eliminated that problem.
What's PDO?
PDO is the object-oriented method for accessing databases in PHP. Let me see where I'm at. I left myself hints. Okay, questions and comments real quickly.
Okay, real quick question. So now that you've built this, cache, whatever you call it.
The image.
Image,
Yeah.
okay. How's the image stored and how big is it?
So right now, the image is only on my computer. I have not pushed it anywhere. Docker image ls, and it is 421 megabytes. Again, I'm starting from a pre-existing PHP-based image.
Sure.
So my code that I added to it added hardly nothing. That image was already that size, pretty much.
Is it stored as like a zip file or something?
I really don't know. I've never needed to know how Docker stores it. It's stored on disk somewhere, and Docker manages it.
It's an open container standard that
Yeah.
pretty much everybody uses now.
There you go.
Yeah.
So it's just
Not
like
just
some,
not just Docker.
like some sort of zip file.
Everybody uses it. It's a standard container standard.
Yeah.
Okay.
But it's a single file. not a file
Kubernetes works the
system.
same way.
Well, conceptually, you think of an image as a single file. It's actually made up of multiple layers of images, but that's, for our purposes, apparently I thought I was in Do Not Disturb mode.
Remember to donate to Neon later too.
So it's made up of multiple layers of images layered over top of each other because you're starting with this image and you build this image and maybe the PHP image used several images. So there's multiple layers, but for our purposes and for the purposes of your conceptually thinking about it, it is a single, thing that is packaged up into that image.
Yeah, I've got a question too. So I hear a lot of folks start Docker by getting this base image, what you're talking about, right? How do you know you got a safe base image and not something that's got some malicious code in it?
Well, that's a question with any package management system, isn't it? Is how do you know it's safe? And you got to know the team that put it on out there for consumption. You got to do your research on it. The images that we're starting from here, the ones that I demoed starting from, are the PHP images from the PHP team. So as long as their login to Docker Hub hasn't been compromised, which is a challenge for all of us, right? Like, is anybody compromised? So you do your best research that you can. And a lot of it depends on your security concerns and the environment that you're in.
For like the hobbyist, or let's say we're getting started, and let's say we weren't capable of building a Linux, from ground up,
Yeah.
whatever. Where would you suggest we start that generally has safe images to begin with?
I mean, Docker Hub is the place where it's sort of the canonical container registry for public images, but I don't know that anybody's vetting those. Again, you have to know the team that put it up there, and you have to trust them. And again, that's just like Ruby gems or packages for PHP Composer. You kind of got to know where your software is coming from, and that's a calculated risk. Yeah.
And there have been problems with like node packages, I'm sure.
Sure. Oh, Node's notorious. Like, it's the worst for sure.
Yeah.
Python too.
Yeah, I know less about Python,
And
but I
Docker.
imagine it's the same problem everywhere. But Node is so big, right, that it's, yes.
How are you managing your sensitive data in Docker?
Not
as a developer, but
In general, yeah, so
in prod.
environment variables can be mounted in, set up at runtime. And I actually, if I get to it, I might be able to speak to that a little bit later, but mostly environment variables. There's also a thing called Docker secrets, which we're using a little bit at work for our bigger, needs, for our certificate needs and stuff like that.
Yeah, but you've got to use Swarm for that, right?
Or Docker Compose. Docker Compose for development, Swarm for production, but they're pretty much defined the same way. You're just pulling them from different sources.
Got it.
So let me spin that down. Okay. Yes.
So when it comes to private registries, do you prefer self-hosting your own, whether that's on-prem or in your cloud hoster?
I actually have never self-hosted my own. I've always used a service. So I was until recently. I'm a big DigitalOcean guy. I do some DevOps on the side for a company I used to work for, a smaller company, and they retained me for their DevOps. And we were using DigitalOcean. I'm actually transitioning to GitHub Container Registry, but I've always used services for it. At work, we use GitLab, and we are self-hosting GitLab, so I guess it's self-hosted, but it's all managed in GitLab. So you say, spin up this container registry, you access it at the same URL, you access GitLab, and so I've never hosted my own without some managing software. But my understanding is it's literally you run a Docker container to host it. So,
It's really easy to do.
Yeah.
They have their
It
own
looks easy.
official image.
It looks easy. I've just never needed to do it. Like, I'm going to pay for hosting. I have to pay for a server. I might as well pay for the service to spin it up and manage it. So that's local dev that we've talked about. Let's talk about production. Well, as we've seen, the Docker file is very powerful. I gave you just a taste, but you can do anything that you can do in Linux in that Docker file. You can use non-Debian-based images and use their tooling for installing stuff, whatever you need to do. So the Docker file really defines the environment for the application to run in. And then what you would typically do is run your build and your CI and push that image to a private container registry, and then you pull the new image on your server and run it. That's of course assuming you're not using a managed service. Most of my usage of this personally, in the company I left was smaller, so we're using DigitalOcean droplets, and they run Docker, and we pull the image down and run it. There is services where you can give, basically point at your Docker file. It builds it, runs it, and manages it, or there's serverless and all that stuff. So there's lots of things you can do, but this is the typical kind of, or at least one flow is to build your image in CI, push it up to that registry, pull it down on your server, and run it. So speaking of that, buzzingpixel.com is my website. I host some stuff there. I take payments for software that I sell there, and I thought I would do a little show and tell.
I like the name.
Thank you. I do not remember where I came up with it. Where do we want to start here? So let's start with the Docker Compose file. So first, right off the bat, you can see I have 3 Docker Compose files that are relevant to what we're talking about today. This is by convention, not by the way Docker works. You can tell the Docker Compose command which Compose files to look at. And so my convention is to start with a base Docker Compose file. And then in dev, I also load the dev file, and in production, I load the prod file. So let's start with dockercompose.yaml. So it looks pretty familiar, right? You've got your app container that you're defining. Docker has this way to load, like I mentioned earlier, environment files. So I'm literally loading the environment from a file on the server. Again, this is small time. There are other ways to manage it if you're bigger and bigger environments. For my needs, I'm running a $10 droplet, it's fine. I have the files stored on the server, and I'm loading them from the server. I think that's still true. I've made some changes recently. The container name is just a friendly name if you're doing Docker PS on the command line. This is my image. So you'll notice this image looks a little different from what we've seen before. It actually includes a URL. So unfortunately, Docker sort of in the tag naming system, it's sort of wrapped up into also the URL of the hosted image. So if you have a URL prefixed over your image, then it's going to figure that out, and it's going to go out there and look for it. And of course, you would need to be logged into that registry if it's private and that sort of thing. So this is the name of my app image. This is the Buzzing Pixel is the GitHub. I don't know, my words are failing me. I'm giving a presentation. It's the GitHub organization. And then the name of the image is buzzingpixel.com-app. I'm just doing some port stuff, not super important. I am hosting my own database. Again, it's a $10 droplet, and it's doing great. So I'm using Postgres for my database. So the DB volume I'm mounting into a slightly different place than what you saw before, but it's where Postgres stores its data. I am using Redis. I'm also using Elasticsearch that powers a search for my issue tracker. So you can see I'm defining several things in my base compose file. So in dev then, I am mounting the entire code base, as I showed before, into my container so that any changes I make are reflected there. And I'm doing some other things. I have a storage directory that needs to persist across restarts. I have a utility script. This is actually so I'm adding a utility container, which has a script that runs every second, I think it is. Basically, I'm just running the script, and it runs some things every second. It's not a huge deal. And I have my app container. So I mentioned earlier I have traffic. I also use traffic in production, not just on my dev machine. And it works, at least with Docker Compose, it works by defining labels that tell it things like what is the URL that I should be looking for, and what's the entry point, should I be serving a secure website, and that sort of thing. So I'm mounting, for some reason I'm mounting the code base in the DB container. I don't remember why. All right, so that's for dev. Actually, I'm showing dev. So prod, I am using traffic, I think. Or is this an older one? This is an older one. So I didn't used to use traffic. That's a more recent phenomenon as I discovered it. Not super important. You should be using Docker Swarm in production. This site has been through a lot of stuff, and so I've never transitioned it to Swarm. It's still using Docker Compose, which is totally fine for the small operation that I run. If you're running a bigger operation, you should be using Swarm. So let's see, I'm telling Docker Compose, which by the way, Swarm reads from the Docker Compose files and they have most of the same settings, so there's not usually a problem there. I'm making sure that the container, if for whatever reason it goes down, there's a fault, a seg fault or something like that, I'm telling it to spin it right back up. That's what restart always means. That's pretty much mostly what I'm doing with this prod file is restart always. So that's the Docker Compose situation. Let's look in the Docker directory. You ever noticed, I don't know if any of you have ever given a presentation, it's much harder to find stuff that you normally have no problem getting right to.
It's expected.
So this is my Docker file for the application. One thing I haven't mentioned yet is that you can build things with an image and then get the results of it, and that's all you need it for. So for instance, I have some front-end assets that need to be built in Node. This is using Node 15, and so I create something called the front-end builder. I'm just naming this the front-end builder, and then I'm running yarn, yarn build prod, and then later, let's go ahead and go down here, I will get the results of that work. There it is, from front-end builder, and I copy the results of CSS and JS into the place they need to be on my actual image in there. So I don't need Node other than to build those assets, so there's no point in having it in my image. So I'm just using Node to build that and then getting the results of that. Here's where the real work begins, where I'm starting from the PHP 8.0.3 image. I install some things that I need. I'm using something called S6 to start and run services. It's not super important for this talk, but that is what I'm using. I'm installing a bunch of stuff that I need for my application to run, such as Postgres, and then I'm installing some PHP extensions. It's much easier to install Nginx than it is to install PHP, so I'm starting with a base PHP image and then installing Nginx, basically, so that my application has everything it needs to run. Nginx, by the way, if you don't know, is a much better server than Apache. You should be using it. I have opinions. Let's see, and then I need Composer because that's our package management in the PHP world. So just some various things that I'm doing here. Copying configuration into place in the container. I mentioned my front-end build already. I'm Composer installing those packages that I mentioned. And that's pretty much it. That's the Docker file for the application. That's actually the only Docker file that I'm using in this project. Everything else is from stock images. Yes?
This is more of a question about the application than it is Docker.
Yes.
But I'm just curious, why are you running Nginx in the same, or setting it up in the same image as the application rather than its own?
Yeah, I used to run different images for those, but one of the things that I've shifted in my thinking is to thinking of your application as a package. Like this image runs my application, not these images run my application. Now that falls apart a little bit when you're talking about caching and databases, but I try to package as much stuff as possible up into my application. There's really, I couldn't find a reason why we wouldn't, and there's several of us in the community now that are kind of thinking this way, which is why wouldn't you want your web server and PHP to be running on the same image? Otherwise, then you have to go out a level into networking and hit it over a port, and then you got the port throttling and all that stuff that happens, and it's just not like TCP and all that stuff. Like let's just do it internally on and manage it internally. So that's the reason. It's totally fine and legit to run two different images, but then you have more images to run and manage and build. All right, so let me go ahead and spin this up. Let's see, I need to get into the right place.
We got about 5 minutes.
Oh dear, okay, I'm already skipping stuff, so. All right, so that's online. Let's go to buzzingpixel.localtest.me. If you don't know about localtest.me, it's just it takes everything and routes it to 127.0.0.1, which is great. I think things are still starting up. There we go. So that is my local dev site for buzzingpixel.com. 5 minutes. See if I can do this in 5 minutes. So I wanted to demo, I wanted to go over the production deployment. Let me see if I can do this real quick. So basically, this is a GitHub action that, and again, I'm using GitHub Container Registry. So I'm building the image, as you can see here, and I'm using BuildX, which is just an even newer way to build images, and it also includes the native ability to push straight to a container registry. So that's what I'm doing here. And then the deployment logs into the server, pulls the latest image, does a few things, which again I'm trying to skip for the sake of time. And then it spins down the old container, which was still running during this process. So the downtime, there are ways to do note zero downtime deployment. Again, this is a single thing. I don't have like blue-green deployments, but so I'm spinning this down, and then I start it back up, and that starts it from the new image that I just downloaded, and the downtime is like 5 seconds. So yeah, and then I'm running migrations and various things, which is all part of that script. So let me see if I can do this real quick. You can see here that demo is a 404. And if I go out to buzzingpixel.com/demo, you get the nice, pretty 404 page and not the dev one. So if I do, let's see, let me just make a class here. Demo action.
I like the way your site looks, by the way.
Thank you. It's Tailwind UI. Yeah, let's see. Invoke, there it is. Gotta get my IDE to work with me here. The server request interface is the first argument, and then the response interface is the response argument. Okay. And then let's see, response, get body, write, hello world, return response, and then we need to route that. So config routes app get request demo action summit class. Okay. Oops, that's my live server. There it is. So hello world. Let me pull up this. Nope, that is not right. What's that? Okay. Live deployments. Add demo page. All right. So this is going to do what I showed in the GitHub action. So if we go out to GitHub, Buzzing Pixel, actions, you can see the workflow is running, and in just a few minutes, that demo page will be live on my site. So I don't know how much time I have left, but
Probably should just search for Apple.
while it's doing that, since I'm running out of time, let's talk about the benefits. As your app needs things, as you write new code that needs new dependencies, you update your Docker file and all the environments get it. It makes your environments easy to set up. We actually have a script at work. You just run .dev docker up. Dev is the scripting that we have locally, our local script, and it does all the things it needs to get your environment up and running. We've honed that and worked on that over time, but it's pretty easy for a new dev to come in and get set up and not have to worry about all that stuff anymore. Containerized deployment, as I just showed, and then currently showing as it's running in the background. Buzzingpixel.com, that scenario is just a small time example, right? There are so many different directions you can go with this, and this is just me and myself operation. I'm not doing a lot of big stuff. Like I mentioned, there are dedicated services where you take a Docker file, you give that service your Docker file, and serverless and all that stuff. It runs all that for you. And there's other ways to do serverless too, but Docker file is one of them. So it makes your application nimble. Obviously, in the past, your bare metal had the most performance, but also the most lock-in, right? Now you're locked into the way you set up the server. VMs had the poorest performance, but marginally better portability. And Docker sort of brings the best of both worlds. You basically run at native performance, and you don't get lock-in, like you take that Docker file and you go to any server that runs Docker. And you control all the app and dependencies. I'm a PHP guy. I was showing PHP. You can run nearly anything that runs on Linux and Docker. Ruby, Python, whatever you need to run, you can run it in Docker. So that's my information. If you want to see my code base, that's a little bit of a mess, as all projects tend to be. But let's see if that deployment has finished running. It is almost done. You can can see now it's on the stage of logging into the server, and it is pulling that image. It looks like it's stopping the old container and starting the new container from the image that we just pulled. It's running those migrations. There aren't any, so it went fast. And that's it. So now we go over here on production /demo. Hello world. Cool. That's Docker.
Awesome.